results of a survey or other data into a two-way table, and we use that table and the results of the tally to determine different probabilities. A contingency table is a cross-tabulation that simultaneously summarizes two variables of interest and their relationship between each other. For this table, you'll see we have 150 adults, and the categories we're using is the gender and the number of movies attended. Now, normally, the number of movies attended could be considered a ratio level data or an interval level data, but because of the way that we've broken it down here, we have it as movies attended as 0, 1, or 2, and 2 or more. So the category here is truly an ordinal category instead. For this example, what we want to do is find out what is the probability of randomly selecting an executive who would remain with the company and who has more than 10 years of service. To do so, first thing we do is we compute the probability of event A sub 1 occurring. Event A sub 1 happens if a randomly selected executive will remain with the company despite an equal or slightly better offer from another company. If you refer to the table, you'll see that since there are 120 executives out of the 200 in the survey who would remain with the company, the probability that event A sub 1 will happen is 120 over 200, or 0.60. The next thing we want to do is compute the probability of the event B sub 4 from occurring. And event B sub 4 happens, it's when a randomly selected executive who has more than 10 years of service with the company is selected. Therefore, the conditional probability that an executive with more than 10 years of service would remain with the company is right here, reads right here, and that is the probability that B sub 4 given A sub 1 occurs. Out of 120 executives in our sample who would remain, 75 have more than 10 years. And for that we need the value that's at B sub 4, which is 75, the intersection of A sub 1 and B sub 4 from the table, which is 75. So the probability of B sub 4 given A sub 1 is the conditional probability that we would randomly select an executive with more than 10 years of service who would remain with the company. Of the 120 executives who would remain, 75 have more than 10 years of service. So the probability of B sub 4 given A sub 1 equals 75 over 120, or 0.625. Now this gives us the answer of the probability of B sub 4 given A sub 1, but we want the probability that both will happen. So to solve the probability for selecting an executive who would remain and who has more than 10 years of service, we use the general rule of multiplication as indicated by the calculation in the box bordered in blue right here. The probability of both event A sub 1 and B sub 4 occurring is equal to the probability of A sub 1 times the probability of B sub 4 given A sub 1, which equals 120 over 200 times 75 over 120, which equals 9,000 over 24,000, which equals 0.375.